So could I have a look, or could I draw your attention to this question here? So this is question 92, because it's slightly different, okay, slightly different. So we have the diagram, which shows the curve. So this curve here is a cubic curve, and we're told it's y equals x cubed plus 2x squared, okay? And we have a line, okay, we have a line. We know that the intersection points are A, B, and C, and we're told the coordinates of those intersection points. We're told that A has the intersection is the intersection point negative 2, 0. We're told that B is the intersection point 1, 1, sorry, negative 1, 1. And we're told that C is the intersection point 1, 3. Okay? We need to find the area of the shaded region. Now, there's a couple of things, first of all, that I want to draw your attention to. Firstly, we are told the coordinates of the intersection points. Are you happy? Okay. But we're not told the equation of the line. We need that. We need that in order to work out the area. But that's okay, because we know that A, B, and C must all lie on the line. Are you happy with that? Okay. So how do we find the equation of a line given a set of points? Perfect. Okay, so first things first, to find the equation of the line, we need to find the gradient. Okay, so we need a point which lies on the line where we've got 3 to choose from, and we also need the gradient. Sorry?
The gradient is 1.
Is it? Do you all agree? Yeah? So how do we find the gradient, just to check?
We can do y2 minus y1 over x.
Absolutely, so let's just quickly do it. Just change in y divided by change in x. I'm just going to use C and B. Why not? I guess we could use A and B. It doesn't really matter. Okay. Change in y over change in x. So let's do 3 take away 1 divided by 1 take away negative 1. Okay. So you get 3 take away 1, which is 2, divided by 1 plus 1, which is 2. So that must come out as 1. Okay. Of course, you could also remember the definition of gradient. Every time you move across by 1 in that direction, it's how many you move up or down by. So have a look. From A to B, we're moving across by 1. And we've moved up by 1, so the gradient has to be 1. Okay? So therefore, to find the equation of the line, okay, I'm just going to use the point negative 2, 0. Negative 2, 0. Okay? I could stick it into y equals mx plus c and then follow it through from there. Okay, so y equals mx plus c. So y is equal to 0. X is equal to negative 2. My gradient is equal to 1. So therefore I get 0 equals negative 2 plus c, which means that c must be equal to, add 2 to both sides, c must be equal to 2. Okay? So the equation of my line, this line here, is y equals 1x, or just x, plus c, which is 2. Does that make sense? Any questions about that? That's just theme, whatever it was, coordinate geometry. Okay, good. Now we have everything that we need, don't we? Okay? Except, have a look at the shape of this curve and where it intersects the line. You notice that there's two separate regions, which means that we can't just work out the area directly. Because if you remember, what we were doing when we work out the area underneath the curve or the area between two curves, it's always the top curve, so it's the integral of the top curve, take away the integral of the bottom curve. Okay, with respect to whatever limits you're looking between. Okay, so it's always the top curve take away the area of the bottom curve, the integral of the bottom curve. Okay, but here we've got an issue, because if you have a look between here, so between negative 2 and negative 1, are you happy the cubic curve is on top and the line is underneath? Okay, but then if you have a look at this area, are you happy it switches? Now the line is on top and the curve is underneath. Okay, which means that we just need to be a little bit careful. We just need to work this out in two parts.
Oh wait, so we just reverse, we deduct the bottom from the top in the first one and do the second one usually.
Yeah, absolutely. So just work out the two areas separately. Don't work it out all in one. So if I call that area 1 and that area 2, just work them out using this idea. But it just means you're going to have to work it out separately because it switches. The curve was on the top in the first area and then the line is on the top in the second area. Does that make sense to everyone? Yeah? Okay, so let's do it. let's calculate the area of area 1. Okay, so to find the area, I take the integral, okay, and it's going to be the integral between -2 and -1. Remember, it's always left coordinate on the bottom and right coordinate on the top, okay? And then I just think, okay, it's going to be the integral of the top curve, which is, in this case, for area 1, which curve is going to be on top? The cubic curve, isn't it? For area 1, the cubic curve is on top, okay? And the line is underneath, okay? So actually, in this case, because I know that I can just end up subtracting the two functions, I'm just going to do it in here. Okay, so I'm going to subtract x plus 2. Does that make sense?
I thought it was going to be in reverse for the first one.
For the first one, which curve is on top? The cubic one. And the line is underneath. So it's going to be top curve, which is the cubic curve, take away the bottom curve, which is the line. Does that make sense? And it just so happens I've combined it together into one integral now, because we saw on that side of the board, it's quicker to do it this way. Okay? So let's go for it. Let's just tidy it up first of all. So -2, -1. X cubed. Then I've got positive 2x squared. Then I've got to take away an x. And I've also got to take away this 2 as well. So just watch your negatives. That's all the hardest bit there is. And then it's just a case of working out that definite integral. Okay? So let's do it. So we get, if we integrate this, what do we get, somebody?
X to the power 4 over 4.
Good.
Plus 2 over 3 x squared.
Yep.
Minus half x squared minus 2x.
Good. Good. And again, it's up to you whether you want to put the plus c in because it's a definite integral. Okay? And then you just stick the -1 in. So we get 1/4 of -1 to the power 4 plus 2/3 of -1 to the power 3 minus 1/2 of -1 to the power 2 minus 2 lots of -1 plus c. And then we're going to take away sticking in -2. So I'm just going to take away 1/4 of -2 to the power 4 plus 2/3 of -2 to the power 3 minus 2 lots of -2 plus c. If you stick all this in your calculator, does somebody get an answer for that?
The whole thing?
Yeah, the whole thing. Just stick it in your calculator, see what you get.
5 over 12.
5 over 12. We happy? Okay. So that's for the first area. That is just for the first area, isn't it?
Yeah.
Yep, good. Okay, that's for the first area. Now we need to work out the area of area 2. But it's exactly the same thing. So area 2 is just going to be, we just need to be careful, we just need to switch these two things around now, okay, and change our limits. So my limit is going to be between -1 and 1. Do you see that? -1 and 1, okay? And it's just top curve, take away bottom curve. So for area 2, what's the top curve? Yeah, absolutely right. X plus 2. Take away the bottom curve, which is? Absolutely. Okay, with respect to x. All right, good. I'm just going to tidy it up at this stage. So I get the integral between -1 and 1. I get -x cubed, because I'm taking away an x cubed. I'm also taking away a 2x squared. And I've got a positive x and a positive 2. Okay, so it's effectively just the negative of this one. Okay. So let's work this out. The area function, just quickly do it. -1/4 x to the power 4 minus 2/3 x to the power 3 plus 1/2 x squared plus 2x plus c between -1 and 1. Okay. And that's going to be equal to, well, let's work it out. We stick 1 in first of all, then we stick -1 in. 1 to the power 4 minus 2/3, 1 to the power 3 plus 1/2, 1 to the power of 2 plus 2 times by 1 plus c. Take away and do the same thing, -1/4 times by -1 to the power 4 minus 2/3, -1 to the power of 3 plus 1/2 times by -1 to the power of 2 plus 2 lots of -1 plus c. Have we got an answer for this?
32 over 12.
32 over 12.
That was fast.
Yeah, well, Denise already done it. Okay. So then, to find the final answer, what are we going to have to do? So we found the area of this one, A1, that is 5 over 12. Okay. We found the area of area 2, that was 32 over 12. If you want the total area, how are we going to do that? Perfect. Just find the two areas added together. So total is going to be A1 plus A2, which is going to be equal to 5 over 12 plus 32 over 12, which is 37 over 12. Is that okay? So there's your final answer. Now here's my question. What if you didn't do it the right way round? What if you were looking at this and going, I can't remember which curve is going to be on the top? Like look at that first area, for example. What if you did it the wrong way round? So you put the line on top. So you did the line, take away the cubic curve. What would happen to your final answer?
Do wrong.
It would just be negative. That's the only thing. Okay? So it just come out as a negative answer. Now you know that because your integration should represent an area, it doesn't make sense to have a negative area. Okay? So all it means, if you get a negative area out, it just means you've done the curves round the wrong way. So even if you did it round the wrong way, I wouldn't worry too much. It's just your answer will come out as negative. So you just make it positive at the end.
So even if we do it in the wrong order, it's not going to affect it, only the negative sign.
It's just going to be a negative at the end here. That's all that's going to change.
Really?
Yep. Okay? So this is down here. But it is important to separate the two areas out. If you don't separate the two areas out, then it kind of goes wrong. You get a bit of cancellation, which happens. Okay? So actually in this case, okay, with all of these questions, you need to visualize what the curve is looking like. Okay? So if you don't know what the curve is looking like, then you're in trouble. So if I ask you a type of question like this, I will always give you the curve. Okay? I will always give you the diagram, in which case you should be able to work out everything you need from there. Does that make sense? So you don't have to worry about drawing the curve. Okay? Are there any questions about this? Okay? It's not difficult, it's just long. Okay, it's not difficult, it's just long.
It's a bit complex though.
It's complex in the sense there's quite a lot of stuff going on, but if you break it down into its individual parts, it's not difficult. Yeah, you can do this. I know you can do this. You can do this. I know you can do this. You can draw curves. I know you can do that. So to find areas, you just need to add stuff together.